Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be jumping into a 10th grade topic, solving quadratics using the quadratic formula. Today's video will be broken into two parts. The first part, breaking down what a quadratic formula is and how to derive it. And the second part, will be using the quadratic to solve our question for today. Be sure to watch the whole video throughout so you know not only how to derive the quadratic formula, but how to use it as well. If you have any questions about what we see here today, or even some of your own homework, feel free to either put them in the comment box below or visit me on Facebook at Tutor Me Senpai. If you find this video helpful today, remember to leave a like, it really helps the channel. Hit the notification bell and the subscribe button as well so you know exactly when I drop my next videos. Well, without further ado, let's break down what the quadratic formula is. When talking about the quadratic formula, the first thing you need to know is it is derived from the standard form of a quadratic. So your ax squared plus bx plus c equals 0. A quadratic in standard form will ultimately lead to our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. But what does this mean for a quadratic? Well, this is really what x equals. So when you're trying to factor this, there might be some times where it's not easily factorable. So we have the quadratic formula that will always give you an x, regardless of whether it's easy to factor or not. You'll always find out what your x's are. Now those x's don't have to be real, they could be imaginary, but it's going to give you what your x is. And when you look at the quadratic formula that gives you your x, you notice it has the same letters as the standard form of your quadratic. Hence why I say it will naturally give you your quadratic. I'll break that down in just a few seconds on how we get from this step to this step, but I want you to see that this b is the same as this b. Same with this b, this a and this a is the same as that a, and this c is the same as this c. The great thing about the quadratic formula is, as long as you remember it, it's not much work you have to do. Once again, as long as you know what your a, b, and c are, you can just plug and chug, and then you'll easily find your x. The more difficult part would be committing this to memory, but as you're using the quadratic formula more and more, it becomes easier and easier to remember. But let's say you don't want to just remember the quadratic formula. What if you wanted to figure out where it came from? Maybe that helps you remember it. If you can always find it, you don't necessarily have to commit it to memory. Well, that's when we're going to start once again with our standard form. We'll start with our standard form, and we're going to try to get something of the form negative b plus or minus the square root of b squared minus 4ac all over 2a. So to get from this step to the final step, we're going to be using completing the square. Now I made another video on completing the square, but I'll just give you a quick shortcut so we can kind of just dive straight into our question shortly after this. So in order to use the completing the square, we're going to have to divide out this leading coefficient, just so we have a 1 as the coefficient and makes things a lot easier. So we divide this and we get x squared plus b over a x plus c over a equals 0. Now we're going to move this constant over to this side so we just have our x's on the left. That's x squared plus b over a x equals negative c over a. Now the shortcut for completing the square is we're going to take this value that's attached to the x, not the x squared, the x, we're going to divide it by 2, we're going to square it, and we're going to add and subtract it in the following way. So we have our x squared plus b over ax plus b over 2a. Remember, we're having this squared minus the same thing. b over 2a squared equals negative c over a. Now the reason why we are adding and subtracting the same thing is because we ultimately want to just add 0. We don't want to change this, and introducing random numbers into this equation is going to change the value. But as long as we add and subtract the same thing, we're not changing the value, we're just changing the looks. So by doing this, we're guaranteeing that this right here is a square, and we can move this to the other side. So this is going to simply be x plus b over 2a all squared equals b squared over 4a squared minus c over a. I went ahead and added this to both sides and did the squaring all in one step. Now let's combine this. This is an unlike fraction, so we're going to have to get the same basis before we can combine these. We're just going to bring this down as is. And we're going to have to multiply top and bottom by 4a. Now we can combine these since they have like bases. Now if you notice, this b squared minus 4ac is showing up in our numerator. Although we have some more work to do, you see we're slowly getting to this point. So now I'm going to actually take the square root of both sides so I can get rid of this square. So that's going to give us x plus b over 2a equals the square root, plus or minus the square root, of b squared minus 4ac all over 4a squared. Now whenever you have the square root of a fraction like this, that's just going to be the square root of the numerator over the square root of the denominator. So we can rewrite this as follows. X plus b over 2a equals plus or minus the square root of b squared minus 4ac all over, what's the square root of 4a squared? Well, that's just going to be 2a. And now you see we're getting really close to this, right? So we're going to get this x by itself and subtract both sides by this b over 2a. So that becomes a negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And they have the same denominator, so we can just combine this to just be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you see, by doing complete the square, you can actually derive your quadratic formula. You don't have to commit it to memory, but if you want to, it saves you a lot of steps, as you see. Now that we've talked about the quadratic formula, how to derive it, and the recommendation to try to remember, because that's a lot of steps deriving it, we can jump straight into our question using the quadratic formula now. So let's write it over here once again. We're going to ultimately get x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, we want to remember that this ABC comes from the standard form ax squared plus bx plus c equals 0. So if you have this tidbit of information, you can easily find your x. So we're going to compare this form to this and write out what our a, our b, and our c is going to be. So in this case, our a is 1. In this case, our b is negative 6. Make sure you keep the signs, that's very important. And our c is going to be 9. So we're going to take this a, this b, and this c and plug it directly into our quadratic formula, and let's see what we get. So we're going to have x equals a negative b, which is a negative 6. So double negative makes it a positive. So we're going to have a 6 plus or minus the square root of, well, b squared. What happens if you square negative 6? You get 36. Minus 4 times 1 times 9 all over 2 times a. Well, a is 1, so it's just going to be a 2. So we can simplify this a little bit further. X equals 6 plus or minus the square root of 36 minus, well, what's 4 times 1? 4. And then 4 times 9, 36. All over 2. So you have a 36 minus a 36. So this is going to cancel it out. And this plus or minus is going to be plus or minus 0. So we really only have one unique root here, and that is when x equals 6 over 2 or 3. So our x is going to be simply 3. And if you look back at our answers over here, you see that this coincides with b. So you see, we could have had a negative 3. We could have had both negative 3 and 3. And the option for 0 was also there. But let's check our work to make sure that this answer is indeed correct. I always advise when you're doing math and you have the time, check your answers. Check your answers. It's going to save you a lot of headaches, and you just want to make sure you give yourself the best chance, especially when you're doing things on a test. So we're going to take this 3 and plug it into everywhere you see an x. So it's going to be a 3 squared minus 6 times 3 plus 9. 3 squared is 9 minus 6 times 3, which is 18, plus another 9. Well, 9 plus 9 gives you 18. Subtracting 18, you get 0. We get 0, so you know that our answer indeed checks out. But let's check the negative 3. And let's also check 0 really quick, and we'll see what happens. Well, for 0, you can easily see that anything that's going to be multiplied by that 0 is going to cancel out, leaving just this constant. And this constant doesn't equal 0, so 0 can't be our answer. So let's jump into negative 3. If we had a negative 3 that was squared, then we subtracted a 6 times our negative 3, and then added 9, this right here is going to give us the same 9, but this right here is going to give us a positive 18. So now we're going to be adding everything, which does not equal 0. Negative 3 does not work. Our answer is indeed B, 3. Remember, if you have any questions at all, put them in the comment box below. If you found this video helpful, remember to leave that like, hit the notification bell, and smash that subscribe button so you know exactly when I drop my next video. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Senpai.